Well, hello, Algebra kids. We are on our final chapter, chapter 13. And today I'm going to introduce you to quadratic equations. We've done a little tiny bit with them before, but first of all, today we'll put them in standard form. Eventually, you're going to be able to figure out what the zeros are. That means the places where this thing will cross the x-axis. And the vertex, or where the start of the parabola is, because these quadratic functions are not going to be linear. They make a U shape, okay? And so how did I get to that point? Well, what will happen, you'll have a function, say that the parent function or the beginning function is just x squared. So what you would do to initially graph these is you would plug in some values for x. So let's do 0, 1, -1, 2, and -2. Because these are not linear, you've got to do at least 5 values. So if we plugged in 0, right, 0 getting squared would be 0. So the y is actually the f of x. So it's like saying x, y, or x, f of x. So if I plugged in 0 for x, f of x would be 0. So I have a point here. If I plug in 1, 1 squared is 1. So at 1, 1, I have a point here. If I plug in -1, -1 getting squared is also 1. So -1, 1 is here. If I plugged in 2, 2 squared is 4. So going to be up here. And if I plug in -2 getting squared is also 4. So as you see, this makes this shape. Okay, so this is the basic quadratic functions graph. So, like I said, we want to put these first of all in standard form. Okay, so this is the standard form of a quadratic equation. This a means the coefficient that's in front of the x squared. Well, in this case, it's a 1, right? Then plus something x, that b might be 5 or -2 or what have you. This one has 0, right? Because we don't have an x term, okay? And plus c equals 0. So again, this one would be plus 0. So we don't have a b, we don't have a c in this one. All right, so let's take an example. So turn to page 576, and it says that this is our equation, and it says to write in standard form and determine a, b, and c. All right, so that means I've got to let this thing equal 0. All right, because I want it to be in this form. Ax squared plus bx plus c equals 0. Now remember, these could be negative. That's okay. So I want to just subtract the 5 and set it equal to 0. Right? So I've got something x squared plus something x plus something. In this case, it's a minus. That's okay. I'm adding a -5. So what is the a in this equation? Oh, it's what's in front of the x squared, right? All right, what's the b? The thing in front of the x. Well, 7, correct? And what's the c? The added on number? -5, right? Okay, so we found it. Pretty simple. All right, let me do the next example. The top of the next page says 5x squared equals -4x. And same directions. I'm supposed to write this in standard form and give the a, the b, and the c. All right, so first of all, I have to move this over so that I set it equal to 0. So 5x squared plus 4x equals 0. Everybody see what I did, I hope? All right, so what's the a? What's the thing in front of the x squared? 5, right? What's the b? What's the coefficient of the x term? 4. And what's the c? Is anything added on in here? No. So c is 0. Okay? I could write plus 0, but why would I do that? It's implied. Okay. All right, so you do the practice, or try this, A, B, and C. So stop the video real quick, do A, B, C, and then come back and check with mine. That's not for you. Keep working. Okay, so with A, I had to move the 7x over, so I subtracted it, setting it equal to 0. The A is what's in front of the x squared. The B is what's in front of the x, and I don't have a C for that one, so I do put C as 0. Now, with B, if I can manipulate my equation to have a leading coefficient to be positive, in other words, the x squared thing, if that could be plus, I want to do that. So do you all see what I did here? I added x squared, I subtracted 3, this 9x was still here, so that my leading coefficient, the coefficient of the highest degree term, is positive. See, I could have moved this negative 9x and put that in descending order, but I would have a negative coefficient, and you shouldn't do that. You should try to have a positive one. So you move it to the right, in this case, and it became plus. The 9x is there, and I subtracted 3. So now my A, the thing in front of the x squared, is 1. The thing in front of the x term is 9, and minus 3 would be my C. All right, and then for example C, or try this C, I had to add 4. So my A is 5, my B is 0. There is no x term, right? So it's like saying 0x. And then my C is 4. All right, the next part that we want to do is to solve very basic quadratic functions. We want to factor them and find what we call the zero, the solutions. So let me show you what I'm talking about with example 3. Now, believe it or not, you've already had problems like this where you had to factor and solve. So what you're doing now is factoring and solving to realize that the solutions are the zeros. They're the place where that parabola crosses the x-axis. So you want to make sure that this is in standard form. In other words, it's equal to 0. And this one was. Very good. Then you look at what's over here and see, can you factor anything? Well, first of all, these have a common factor of 5 and x, don't they? Yes, I could take a 5 and an x out of both of these. So I write that common factor and then see what I have left when I factor that out. So 5 into 20 is 4, x into x squared is x. Okay, so I have factored 5x out of here. Now, 5 into negative 15 would be negative 3, x over x cancels, and then of course this is equal to 0, just like that was. Okay, so I factored 5x out of both terms. So now, just like in the past, you've had this before, if two things are multiplied together and they equal 0, then either this has to be 0 or this has to be equal to 0, right? Two things multiplied together to give me 0. One of their values has to be 0, right? 7 times 0 is 0. Okay. Well, 5x equals 0, I would just divide by 5. 0 over 5 is still 0. So x is 0 is a possibility. Or I would add 3 and then divide by 4. So the other possibility is 3/4. So you have found the zeros or the solutions of this equation. Okay, so once again, you set it equal to 0 and you look for a common factor, or if it's a trinomial, you may have to factor it into two binomials, which I bet that's the next example. Oh, well, they first want you to try this on your own. So let's take a moment and let's do D and E. So follow what I did on example 3. So for D, I see that it's in descending order, right? So I saw that an x could factor out. That left me with x times 3x plus 5. So my two solutions, or my possibilities then, are x is equal to 0, right? It's by itself. Or this binomial is worth 0. So I solved it by subtracting 5, dividing by 3, and those then are my two solutions. For E, I saw that 2x could factor out of both of those. So I factored 2x out. It left me with 5x minus 3 equals 0. So either this is worth 0 or this is worth 0. So here, of course, x is 0 because 2 times 0 equals 0, or I could divide by 2. Anything with 0 over something is 0. Here I added 3, divided by 5, and got my solution. All right, so the last part, let me try example 4, and make sure you guys can handle this. I'm sure you can. All right, now you're told here to solve. So that means you're first of all going to set this equal to 0. All right, so that means we've got to move the minus, the 6y, we've got to subtract it from both sides. And we have to add 18 to both sides. That way these will cancel, and I have 0 on this side. So over here, I'll have y squared minus 11y plus 24. Everybody see that, I hope? Now, this is in standard form. The A is 1, the B is negative 11, the C is 24, okay? There is not a common factor, so I can't pull that out, but this is a trinomial that can be factored into two binomials. Yep. So by trial and error, I know that this factors into y minus 8, y minus 3. Again, you're undoing FOIL. You're putting in two binomials. You're going to check your work with FOIL and make sure that this equals this, and it does. All right, so in this case, what are your two solutions? Well, y minus 8 is 0, so what would y have to equal? Positive 8. For y minus 3 equals 0, what would y have to equal? 3. So these are your two solutions. Okay, so these you didn't take a common term out because it was a trinomial. You factored into two binomials and got your two solutions. All right, so let's take a moment, do F and G. Please try them on your own and get your two solutions, and then check with what I have up on the board. So for F, it was already in descending order, so I just had to do trial and error and find the two binomials that would give me this product. So you may have to try some different combinations. Do FOIL, make sure that this equals this. You have your pluses and minuses in the right spot. All right, so once you get it, then you say either this binomial is worth 0 or this one, okay? So here I added 2, divided by 3, and here I subtracted the 1. All right, and then over here on this one I had x squared plus 4x plus 8 equals 8x plus 29. I wanted to set this equal to 0, so I subtracted 8x, I subtracted 29, these canceled and left me with 0 on the right. Okay, I collected like terms, so x squared minus 4x minus 21 equals 0. Then I know that this is a trinomial that factors by trial and error into this. So my two solutions, my zeros, are positive 7, negative 3. All right, so a fun little start to chapter 13. You may need to watch this again. You might want to read through the lesson. Like I said, this is it's a challenging little chapter. I'm going to try to make it as easy as we can here at the end. But you do your part, I'll do my part. Have a great day, everybody.